Welcome to the lecture on weathering in soil. First, I don't know, I just like this guy. He's so cute. Plus, he's got a good dance going on. Where would we be without weathering? Wouldn't that be a good thing? I mean, wouldn't the earth be a lot cleaner if we didn't have all that stuff wearing out? You wouldn't have to dust your house. You wouldn't have to blow off your back porch or your driveway. Wouldn't that be a good thing? Take a look at this rock. This is a piece of granite. I'm trying to remember where I took this picture. I think it's up near Yarnell. I have some land up there. What's that red stuff and what's that green stuff? Is that orange? Whatever. What's happening to this rock? And why is this rock round instead of square? I mean, didn't start out in this shape. Why is it that shape? And where did all this stuff around it come from? And was the rock always just sitting there? These could be some hints. This is an old statue, I think, on a church in England, and it wasn't made this way. Apparently, it's kind of worn out, and these rocks weren't made this way. Something has worn them out over long periods of time. Why is this water red? This picture was taken really near the first rock with the orange and the green on it. This is all related, believe it or not. Okay, it's not really chapter 5. Sorry, I stuck the wrong thing in there. But by the time you're done with this, you should be able to give specific examples of how mechanical weathering works. You should be able to identify in images chemical weathering and explain the processes. You should be able to describe why mechanical and chemical weathering rates vary. Identify erosional features and explain their causes. What do I mean by features? We're talking about spheroidal weathering, balancing rocks, hoodoos, slopes, exfoliation domes, and talus slopes. You can correlate particle size and weathering rate. Give examples of how chemical weathering affects minerals differently. Identify which rocks are most susceptible to either mechanical or chemical weathering. Trace how soil develops and erodes. Explain where the best soils will occur and why. Explain the effect of climate on soil. Explain the consequences of soil erosion. And be familiar with different soil types. This is all good stuff to know. It's a blank page. Just relax for about 1.3 seconds. That's enough. Okay, 2 types of weathering. One, mechanical/physical. Some books call it mechanical, some call it physical. And it's simply breaking the material into pieces. The other one is chemical, altering the molecules of the rock. Let's say you have an old Buzz Lightyear toy, and you take it out in your driveway and you smash the heck out of it. You ride your bike over it. Have you really changed the molecules in Buzz Lightyear? Correct answer? No, he's still Buzz Lightyear. Well, kinda. And the plastic is still the plastic. Nothing has changed. However, if you dunk that into acid, or if you leave it out in sunlight where ultraviolet breaks the bonds that hold the molecules together, you're subjecting Buzz to chemical weathering, not just mechanical weathering. I'll stop there. Types of mechanical weathering in which the rock simply breaks into smaller pieces. Still the same stuff, it's just in smaller pieces. Here you go. Exfoliation, pressure release, ice, frost action, frost heaving, ice wedging, root pry, and salt spalling. What the heck are these? Well, let me show you. Exfoliation. The girls especially know about this. You get these little loofah sponges and you exfoliate. What's that mean? You're rubbing the outside layers of your skin off, like the outside layers of an onion. Rocks do the same thing too. No, they don't have a big loofah at night. Somebody comes by and scrubs them. But take a look. This is granite and it's peeling off in sheets just like the onion and just like our skin does if we look at it under a microscope. What's going on here? Well, in this case, the old theory was that it was caused by heating and contracting on the outside layers of the rock, and that may cause some of this going on. But there's something else going on in this case. There used to be a lot of granite and a lot of material on top of this mountain. Little by little, that has gone away, and as that has gone away, this mountain is actually bounced up, and as it bounces up, you end up with these joints parallel to the surface. They aren't fractures because there's no real movement along here, no faults, I should say. They're just joints, breaks in the rock. Here are people and this scares the heck out of me, at Half Dome Yosemite, and here you can see big sheets, exfoliation sheets. If these people slip and go down, this could be really bad. So, oh, I don't like to think about that. Where would they go down? Down this way. Not a good thing. Take a look. This entire mountain called Half Dome is an exfoliation dome. It's peeling off on the outside like an onion skin. Again, this usually is caused by pressure release. There is heating and cooling involved too. Any of you who've been around the country may know where this is. I got my picture taken back here a long time ago. It's in the south. This is a really big mountain made out of granite. A few of you may have figured it out. This is Stone Mountain, Georgia. It is a really large exfoliation dome. And it's a really good place for rocks to slide down if you're trying to hike up and maybe get hit by them too. I love this kind of stuff. Now, here's an example of what goes on. When you remove the weight from over the rock begins to expand upwards and you get these sheet joints forming. This is called spalling. Next type of mechanical weathering. Most substances contract when frozen. If you've ever put a balloon into the freezer or left a balloon outside and it got cold, you know what happened to the air in the balloon. It wasn't just that it escaped. The air actually took up less room. The particles were moving less quickly, therefore the whole volume decreased. There's a weird thing that goes on, however, with water. When water goes from a liquid to a solid, it requires more room. In fact, it expands about 9%. You may know about this already. Have you ever taken a can of Pepsi and put it in the freezer and your mom says, hey, you're going to leave that in there and bad things are going to happen? You go, no, Mom, I'm going to remember. Then a few hours later, maybe the next day, your mom says, get in here. You know what I'm talking about? You leave a frozen soda in the freezer and it's going to bust. Water pipes that freeze will burst. You can break the copper. Even iron breaks, and even rocks break. When water gets down into the rocks, they get wedged apart by the frost or the ice. This is really kind of cool. Well, actually, it's kind of cold. But ice is incredibly powerful. It's slow, but it's powerful. Here, on the side of Mount Kenya, you end up with little piles of rock being uplifted by frost heaving. You don't have to go to Kenya to have this happen, though. Here is a swimming pool, which doesn't freeze at night, but water got underneath this cool deck. It froze. The water expanded when it turned to ice and lifted the sidewalk. Not a good idea. There's probably a good reason not to put grass next to concrete. In this case, I think this is a sidewalk in England. I can't remember. But these neat little pieces of slate, a metamorphic rock that makes the sidewalk, are being lifted up when water gets under them and expands. The same thing, by the way, happens in Flagstaff. We make the roads up there out of cinders, lapilli, basalt, and it has all those holes in it. Well, the snow comes along in Flag, and it melts, and the water gets into the little holes in the vesicular basalt, and it freezes again, and it breaks apart the basalt. Well, if your road's made out of that, you end up getting all those potholes. Why do they keep making roads out of basalt and ending up with potholes? Well, there's a lot of basalt around there. It's better than hauling in stuff from a long way away. When you end up with a lot of mechanical weathering, you end up with something called, and there's a hill involved, you get something called a talus slope. Big pieces of screed or material come down the hill and pile up. These are great places for pikas or marmots, little rodents that live up in the Rockies. There is a huge talus slope in Four Peaks, and back in the 1980s, a boy and his father were trying to walk across the talus slope, and one of them, we don't know who, dislodged a rock, which then started an avalanche, and that was the end of that. You don't want to know the details. Here's a talus slope up in the Sierra Mountains. What's going on up here? Some kind of weathering, which is peeling off these rocks, and they're all stacking up here. But here's Picacho Peak, down between Phoenix near Tucson. Notice no talus down there. Why not? What do the Sierras have going on that Picacho Peak doesn't have going on? Here's a hint. This. You don't have frost wedging occurring. This is Svalbard Island. I just love saying that word. Svalbard Island, north of Norway. It's a beautiful area, and it's also very cold. Beautiful talus slopes coming off these cliffs. And here's Four Peaks. This is, I was supposed to tell you the story right about here, but I got so excited to tell you, I got ahead of myself. And here we are in Flagstaff. Anytime you make roads out of something that is permeable or porous, you're going to end up coming back and patching it again and again and again. Now, something else that attacks rocks. This is kind of sad, but you've got ice attacking the rock, you've got pressure release attacking the rock, and then plants start attacking the rock. This is just wrong, and it's got to be stopped. If you want, just log into www.respecttherock.com and donate to try and stop this kind of thing. It's wrong. That's a joke. Little teeny seeds can get down in the rock, and when they sprout, they grow slowly. It's not a big deal. But little by little, as they expand, the roots pry apart rocks. Growing up, we had our favorite sidewalks where we would roller skate or skateboard. And some of them actually had little jumps caused by trees growing underneath the sidewalk. If you didn't pay attention, you were going to take a crash, but that's okay. Part of the fun. Is this a big deal with one tree? No, but keep in mind a good portion of the earth is, at least the dry earth, is covered with plants, and these plants are always weathering the rock. One more thing here, mechanically. If you have water, and in the water there's salt, and you spill the water onto the concrete, it will soak in. The water will evaporate, but the salt crystals will stay behind and they will start organizing into cubic crystals. And as they do, they will peel apart the concrete. If you ever have a water softener leak in your garage, this is bad. Rinse it out right away because the salty water from the water softener will go into the concrete, the water will evaporate, the salt will expand inside the concrete and start peeling it off. This is called spalling. The same thing can happen in nature when you have lots of naturally occurring salts. And here we go again, what I was talking about, thermal expansion and contraction. I think this is out toward Yarnell, but I can't remember. It tends to form round boulders. These are called tors, and tors usually have really nerdy guys standing on top of them. And sometimes other people. This is down toward Florence. We are going to stop there. Part 2 will be all about chemical weathering. So see you in just a bit.